In this question, number 25, it's more of a challenge in that it's a longer question because, as you can see, we're balancing 4 elements rather than 3. Just to add on to that challenge, you can see that the oxygens are separated between 2 compounds on either side of the chemical equation, and that also can cause problems too. There are no polyatomic ions that stay together, so we don't have to worry about those. So I'm going to go ahead and just count the number of each element on either side of the equation. So I'm going to have 7 carbons, 3 nitrogens, 5 hydrogens, and then 6 plus 2 gives me 8 oxygens on the left. And on the right, I have 1 carbon, I have 2 nitrogens, 2 hydrogens, and 3 oxygens split between 2 compounds. Of course, numbering the elements correctly in the beginning will lead to a better attempt at balancing the equation. So first of all, I'm going to balance the carbons first. I have 7 on the left, so I'm going to put a 7 on the right. That gives me 7 carbons, and then it's going to change my oxygen count. I have 7 times 2 gives me 14, plus 1 is going to give me 15, I believe. 7 times 2, 14, plus 1 will give me 15 oxygen. So that balances out my carbon. The next thing that I notice is going to be my nitrogens. I have 2 nitrogens here and 3 nitrogens there. Sometimes when you have this, the easiest thing to do is to swap the subscripts and use them as a coefficient. This is what that looks like. I'm going to take the 3 and put that in front of the N2 here, and then I'm going to put a 2 over here. And what that does is I have 2 times 3 is going to give me 6 nitrogens, and 3 times 2 gives me 6 nitrogens. So sometimes when you swap the subscripts, when you have a situation like this where they're only 1 apart, that helps with your balancing as well. Now you notice that when I put the 2 in front of here, it's going to change my carbons again, but that's just one of the things that happens. Try not to worry too much if that changes. So I have 2 times 7 gives me 14 carbons, 2 times 5 gives me 10 hydrogens, 2 times 3 gives me my 6 nitrogens I've already done, and then 2 times 6 oxygens give me 12, plus 2 gives me 14 count on my oxygens there. Now you can see that I have my 6 nitrogens, but my carbons are out of whack, so I'm going to change that. I have 7 carbons on my right, so what I want to have is 14. So I'm going to go from 7, and I'm going to put 14 in front of that. That will fix my carbons to 14. Of course, my oxygens are going to be a lot different now. 14 times 2 gives me 28, plus 1 is going to give me 29 oxygens, but I'm not going to worry about those yet. I'll fix those at the very end. Now that my carbons and my nitrogens are balanced out on each side, it's time to do my hydrogens. I have 10 hydrogens on my left side. 2 times 5 gives me 10. It looks like I have an easy fix here. If I just put a 5 in front of my water compound here, 5 times 2 gives me 10. And then I just have to do a recount of my oxygen. So I have 14 times 2 is 28, plus 5 gives me 33. Whoops. So my new count on that side is now going to be 33. And then I'll just need to find a coefficient here to balance out on my right-hand side, on my left-hand side. So this is how I figure it out. If I have 33 on my right, first of all, I need to take into consideration that I have 2 times 6 here is 12. So I have 12 oxygens already of the 33. So I'm going to go little calculation here. 33 minus 12 is equal to 21. And this is where I'm going to use a decimal. I need 21 oxygens. So 21 divided by 2 gives me 10.5. So that's going to be my coefficient for that. And then I will have 33 on that side. By putting that 10.5 in front of the O2, I do balance out my oxygens, but I can't keep that decimal. And whenever I use a decimal, I have to fix it. I have to make it into a whole number. And the easiest way to make 10.5 into a whole number is to multiply it by 2. But whatever I do to that coefficient, I also have to do to the rest. So what I will get then is 4 C7H5N3O6 plus 21 O2s, 28 CO2s, oh, I have to multiply that one too, plus 10 H2Os, plus 6 N2s. And then that will balance out all of the elements correctly, and making sure that, this is a 21, that my coefficients are all whole numbers as well. So that one takes a little bit more time because there are more elements to work with, and also the coefficients are quite large, but again, that's okay as well.